This part of the preparation is about payback period. So payback period, we just learned about break-even analysis, and that's when you want to not solve for just a net present value or two options and compare them. You will compare the net present value of the two options, but you find some variable, some value of some variable in the problem such that the two net present values are equal. And so that value could be a time, it'd be a quantity of units produced. Payback period is a simplification of that concept. It's a restricted case of the same idea. It's to when that variable that you're solving for is time, not quantity of something or number of miles. It's restricted to time, and it also effectively, when you're calculating net present values, you always assume the interest rate is 0%. You can just sum up dollars between different years without being concerned about the interest rate. That's the convention. You get to cheat. So it's easier. It's simply easier. So if you know how to do break-even analysis, you'll be fine with payback period if you just remember you're solving for time and you have an interest rate of 0. So here's the definition would be the length of time for the cumulative net annual profit to equal the initial investment. That's a fancy way of restricting it to the same case that we're looking for the time for the net present value of the profit to equal its initial investment, or for the option to pay for itself. So it doesn't consider the interest rate, or it assumes the interest rate is 0, is another way of thinking about it. So here's an example. A ski resort installs 2 new ski lifts. The cost is $1,800,000, and the resort expects annual gross revenues to increase by $500,000 per year, while it incurs an annual expense of $50,000 for lift operation and maintenance. And the problem says that you'll assume an interest rate of 15%, but you know that you'll get to ignore that when you're calculating the payback period. And I'm going to contrast this against what's the break-even time. You could also ask, what is the break-even time? And the payback period would not consider the interest rate, or it would say the interest rate is 0. What's the break-even time? You do the same sort of thing, except you go ahead and use the interest rate as 15%. So we want to find basically the time for the cost to equal the value, right? As the name suggests, it's when payback, when you get paid back. So basically you're looking for a net present value of 0. So NPV, in this case, we're going to find out what it is. We're going to say we've got this negative 1, let's do this thing in thousands of dollars, plus 500,000 minus the 50,000 for maintenance, and those are every year. So we would think if we were doing proper net present value calculation, then we'd multiply that by a discount factor, which is the present value given an annual value for an I% interest, and n is the number of years. Now, if you don't have any interest, then the discount factor that takes an annuity and turns it into a present value, if you have 0 interest rate, then that is just n. So let's start by doing the payback period. So in that case, we have negative 1,800 plus 450 times the interest rate, in this case, is 0, n is equal to, this discount factor is equal to n. And we say this is equal to 0. And we just solve this equation, so 450 times n is equal to 1,800, and we can solve n is equal to 4 years. That's it. That's as simple. It's very simple. This is just a simplification of the idea of break-even analysis. This is break-even analysis when you have just one option. You're setting the net present value equal to 0, or the costs are equal to the benefits. And we also have the simplification that the interest rate is effectively 0, so the discount factor, at least the one that converts to a present value from an annuity, is just the number of years. Now let's calculate the break-even time, just to see how it differs. Break-even time. And we'd start out the similar way, 1800 plus 450, but we need to multiply that by this discount factor, P over A, I, N, and that equals 0. So we've got 450 times the discount factor is equal to 1800. And so we know that the discount factor, P over A, I, N, has to be close to 4 with the 15% interest rate. So I is equal to 15%. So that just means we need to look in the discount factor tables corresponding with 15% and find the value of N that gets us the discount factor being 4. Okay, so switch over to our discount factor table. We see that we've got the discount factor table for 15% right here. We need to find how many years, after how many years is P over A close to 4? So somewhere between 6 and 7 looks like the right answer. I guess we could kind of hone in on that by playing 6.6, something close to that. If we wanted to be fancy, we could of course do the same thing we learned recently. We can go into data, and we could go to what if analysis, and we could go to goal seek, and we want to set this cell to the value of 4 by changing the number of years. And there we go, 6.556 is the answer that we'll write. So N is equal to 6.556. Another way we could have done that, of course, is by looking at our discount factor tables. If we were doing it on the FE exam, we would have found that, all right, for the 15% discount factor table, which isn't here, we'd say for the 12% discount, well, it would be really difficult actually. I think on the exam, you'd probably have to have a problem where it gave you the proper discount factor tables. But you could always go to the formulas, of course. Right? Instead of using the tables for the discount factor, you could say, what is the P over A formula? And you could solve for N, given the interest rate of 0.15. Yeah, plug this into your equation for the discount factor and solve for the N that gives you the discount factor you're looking for.